All right, we're doing the Algebra 2 Unit 5 review, quadratic functions, equations, and inequalities. And this is for those of you that need an explanation, maybe need to hear it again, or you were absent and didn't get it, or we didn't get to it in class. So if you need to, you can fast forward to the problem that you need, or you can go through the whole thing, however you want to do this. And I'm going to try to go as quickly as I can, and you're able to stop and rewind, and so I can go a little faster. Greg is looking at the graph of a parabola. Its vertex is -2, -25. It intersects the x-axis at -7 and 3, and it intersects the y-axis at -21. What are the roots of the equation he has graphed? Okay, so let's just kind of look at it. If we're thinking about it, -2, -25 would be down in this quadrant somewhere. It'd kind of look like this. This would be the vertex, -2, -25. Okay, the roots are going to be at -7 and 3, which I haven't graphed that very well because 3 is positive. And so it intersects the x-axis at -7 and 3 and the y-axis at -21. Okay, these are your roots. So our roots are going to be -7 and 3. The x-intercepts are the same thing as roots, which are the same thing as zeros, which are the same thing as solutions. Okay, solve. Number 2, solve 0 equals 6x squared minus 135 minus 1200 to the nearest hundredth. Use the quadratic formula or graph on the calculator. And I'm going to do this using the quadratic formula. If you want to do it on the calculator, that's fine, but you have to be able to see it on your calculator. So you're going to have to change your window and find it. But when it says solve, we're talking about solutions, or where it crosses the x-axis, if it does. Now it may not, we'll have to see. But we're going to do the quadratic formula, which is a, b, and c. We need these three numbers. A is 6, b is negative 135, and c is negative 1200. Big numbers. Then we're going to do the discriminant so we can see what kind of solutions we're going to have. And this helps us break it down into smaller chunks. So we're going to put negative 135 squared minus 4 times 6 times negative 1200. Okay, then use your calculator. And make sure you do parentheses. Parentheses, negative 135 squared minus 4 times 6 times negative 1200. We get 47,025. 47,025. Okay, that means it's a positive number, so that means we're going to have two real roots here. Okay, so now we're going to use the quadratic formula, which is on your formula chart that you will use on your test. Negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so the opposite of b is 135 plus or minus b squared minus 4ac, we know, is 47,025 divided by 2 times a, which is 6. Okay, so let's see what the square root of 47,025 is. And it doesn't come out even. It's 216.85. So 135 plus or minus 216 we'll just go with 0.9 over 2 times 6 is 12. Okay, so now we have two different answers. We have x equals 135 plus 216.9 divided by 12, and x equals 135 minus 216.9 divided by 12. Okay, so we're going to put that in the calculator, 135 plus 216.9, and push equals, and then divide by 12. So 29.3. And 135 minus 216.9 divided by 12, negative 6.825. We can just leave it at negative 6.8. And this is approximate now because we use decimals. We use the wavy equals. Okay, don't let the big numbers scare you, just plug them in. Okay, number 3, find the vertex of the following function. Okay, the vertex is either the maximum or the minimum. We're going to plug this in. X squared minus 10x plus 65. And let's start at zoom 6 and see if we can see the graph. Okay, we cannot see this anywhere. So try zoom fit, which is zoom 0. There's zoom fit. We go to zoom and zoom fit. Scroll down to zoom fit. Okay, and there is our vertex. It's going like this. And so now we can find the vertex. We're going to do second trace or calc here. And second calc. And since this is a low point, we're doing a minimum. So we'll do 3 minimum. Okay, and then we have to put the cursor to the left of it, which is pretty much almost to the left of it right now. Push enter. Then we have to get to the right of it. See if I can see the cursor. Hard to see. It may already be there. We'll just have to guess. Aha, so the minimum is 5, 40. Which is right here. Okay. The function y equals negative 64 parentheses x minus 2.5 squared plus 400 models the store's profits in dollars on potato chips, where x is the price of a bag of potato chips. What should the store charge for a bag of potato chips to maximize its profits? What is the maximum profit earned? So y represents the profit, and x represents the price of the bag of chips. So we're going to have to put this in our calculator. Negative 64 parentheses x minus 2.5 squared plus 400. Okay, let's go back to zoom 6, which those big numbers is probably not going to be on here. Oh, we see part of it though. Okay, it looks like the left hand side of it maybe. No, it could be up here. So let's see, zoom fit. Let's see what that does for us. Ooh, that's good. Okay, so we want the maximum because we want to maximize our profits. So we're going to do second trace maximum, and we'll move it to the left, which is already to the left. And we'll move it over to the right of it. Okay, and see these little arrows? It tells you what you have, where you put your left cursor and your right cursor. Then push enter. And so we get 2.5, 400. Now what do you notice about 2.5, 400? It is in the problem. That is the vertex, or the maximum. Okay, and 2.5 is your x, 400 is your y. Okay, so the max, what do they have to charge for the potato chips? That would be the price, or x. They're going to charge $2.50. And then the maximum profit would be $400. So they're going to charge $2.50 for the bag of potato chips, and they're going to make a profit of $400. And that's the maximum they can make. All right, number 5, how does a graph of f of x equal negative 3x squared compared to the graph of g of x equals x squared? Well, if you can't remember what the negative 3 does to the graph, we can graph it. Okay, we can graph x squared, which is our parent function, and then I'm going to go over here to the left. I'm going to make y2 dark, and I'm going to do negative 3x squared in it so I can tell them apart. And I don't want that. I want zoom 6. That's not going to look so good. I'm going to go back to zoom 6. There's the parent function. And there's the negative 3x squared function. So what happened? It flipped or reflected over the x-axis, and it got narrower, or we're going to say it was a vertical stretch. Okay, find the discriminant and describe the roots of 4x squared minus 12x plus 9. The discriminant is b squared minus 4ac. Now this is on your formula chart. You look for quadratic formula, and it's the part underneath the square root. Okay, so we're going to plug in for b. Well, we need to write down what a, b, and c are. A is 4, b is negative 12, and c is 9. So then we'll plug in for b, negative 12 squared minus 4 times a, which is 4, times c, which is 9. So negative 12 squared is 144. Okay, and then 16 minus 9, or actually I'm just going to go ahead and do the whole thing in my calculator. So parentheses, negative 12 squared. Always use parentheses. You will get it wrong if you don't. Minus 4 times 4 in parentheses times 9 in parentheses. Okay, and that gives us 0. It's interesting. Okay, we're going to have 0. So I'm going to mark that out and put 0 here. Okay, so what kind of roots are those? Remember, this goes underneath the square root, and so the square root of 0 is 0. What kind of roots is 0? It's going to be one real double root. Okay, number 7. Use the table of values for the quadratic function to determine between which two x values will have a 0. Okay, so here are the x values, 1, 2, 3, 4, 5, and we're trying to figure out where a 0 is going to occur. And if you look at the y's, the y's go from negative 5 to negative 4 to 4 to 11 to 20. Okay, so if we're kind of looking at that on a graph, negative 5 is down here, negative 4, okay, and then from negative 4 to 4, we're going to cross the x-axis and we're going to have a 0 between here. We're going to have a 0 between these two. When the sign changes, that's when you have a 0. Okay, and it says between which two x values. So we don't want to put between negative 4 and 4. We want to put between 2 and 3. So that would be B. Okay, number 8. Okay, this is something you haven't really seen before, but it's not that difficult. Okay, we're going to solve for x. We're going to cross multiply. Well, cross multiply means you do 2 times 3 and 5 times negative x squared. Let's do 5 times negative x squared first. That would be negative 5x squared equals 2 times 3 is 6. Divide by negative 5. So x squared equals, dadgummit, I didn't do the right thing. Okay, we're going to make this 25. That was supposed to be 25. So this would be a negative 25. Okay, that's better. So we have 6 x squared equals okay, let me start over. Let's start over. So we'll have 25 times negative x squared. That would be negative 25x squared equals 2 times 3, which is 6. Sorry about that. That's supposed to be a 25. Then we'll divide by negative 25 to get the x squared by itself. So x squared equals a negative 6 over 25. To get rid of the x squared, we square root both sides. Okay, and I know the square root of 25, that is 5. So I'm going to say x equals, and anytime I take the square root and it's equal to something, I have to do the plus and the minus, or the positive and the negative. Okay, so we're going to have on the bottom, we're going to have a 5. So I know the square root of 25 is 5. But on the top, I know the square root of a negative is I, but I'm going to leave the square root of 6. Okay, find the discriminant and describe the roots of 25x squared minus 10x plus 1 equals 0. Okay, discriminant, is, once again, is b squared minus 4ac. And so a is 25, b is negative 10, and c is 1. So we're going to plug in for b squared, negative 10 squared minus 4 times 25 times 1. Okay, so that's going to be negative 10 squared is 100 minus 100, that's 0. Okay, so this is a, one real root, and it's a double one. Okay, the path of a projectile can be modeled by the function below, where t is the time in seconds and h of t is the height in feet. Which of the following could be the approximate time when the height is 150 feet? Okay, so, okay, if t is the time, t is time, height, this is height in feet, so we know that this goes here. 150 equals negative 8t squared plus 48t plus 100. We're going to put this in y1 and this one in y2 and see where they intersect. Okay, so negative 8x squared plus 48x plus 100. Okay, we'll try zoom 6 first. If that didn't work, we'll go to zoom fit. Okay, we can see part of it. Let's try zoom fit and see if that helps us any. Oh, that's pretty good. Now we're in Y2, we're going to put 150. Okay, and we need to be over here. So I need to make my X max larger so I can see that. So I'm going to go to Window, X max, I'll make it 2,000 instead of 1,000. Okay, that didn't work. So that was Y max. No wonder. Keep that one. Make this 20 instead of 10. Okay, now we know, we see that it intersects here. We always want the positive intersection, not the negative intersection. So now we do second trace or calc. Okay, number 5, intersection. So second trace 5, intersect. Enter on first curve, enter on second curve, and then you can move it over to the one that you want to find. Instead of this one, we want this one. Push enter. And it'd be 13.7 seconds. I hope I put that in there right. Negative 8x squared plus 48x plus 100. Oops, there's my problem. Okay, didn't put it in correct because I didn't think that was the right answer, so we're going to graph it again. I got rid of the 0. You're probably wondering why you couldn't see anything, why yours didn't look like mine. Now I want to find this intersection. Second, trace, intersect. First curve, second curve, and it's right there. Okay, 4.7. That's better. 4.7 seconds. Okay, sorry about that. I had put an extra 0 and had to take it off. Okay, number 11. Solve the following inequalities. Okay, first of all, we have to get it equal to 0. Okay, so we have x squared. We'll move this over, it'll be minus 10x. Add this, plus 25 is greater than or equal to 0. Okay, now you can do one of two things. You can factor this, x times x, and 5 times 5, minus and minus. Okay, but we still need to put this in the calculator to see when is it above or below. We need to graph it, see what it looks like. So let's clear this, and you can graph it this way or you can graph it this way. I'll just do the first one. X squared minus 10x plus 25. Zoom 6. Okay. So when is the graph? This is greater than. So when is it above 0? Well, it's above 0 or equal to 0 the entire time. And there is one root, which is 5. But the entire time. So everything is above 0. So this would be all reals. Okay, the next one, plug this one in. You can factor it first to see where the roots are going to be. This would be x, and let's see, minus 4, no, minus 6 minus 2. I think that works. Negative 6 times negative 2 is 12. And then we have a negative 2x and a negative 6x gives us a negative 8x. So our roots, or our x-intercepts, are going to be 6 and 2. Okay, so let's graph this one. X squared minus 8x plus 12. Okay, so 2 and 6 are our roots. And it says when is the graph less than 0? So when is it below 0? So let's make a sketch. This is 2 and this is 6. It's 2, 0. This is 6, 0. Okay, so it's when it's right here. That means x is between 2 and 6. And so we put a 2 on the left, less than signs, and a 6 on the right to show that x is between 2 and 6. And there's no equals because there's not an equals in the problem. Okay, let's get this one equal to 0. So x squared plus 2x, and then we'll subtract 15. So x squared plus 2x minus 15 is greater than 0. And then you could factor this and see where the roots are if you want to. X times x. 3 times 5 is 15, and we need a positive 5 and a negative 3, and that will give us a positive 2x, and negative 3 times 5 is a negative 15. And then we'll graph this one. X squared plus 2x minus 15. Okay, and it wants to know when is it greater than 0. So when is it above 0? And that would be up here. And this is a negative 5. So our roots here, I should have put that down. Roots are the opposites, 3 and negative 5. Okay, so this case, we're going out like this. And so x is less than negative 5 points this way, or x is greater than 3. Okay, Mark is building a rectangular fence for animals using the riverbank as one side. He has 120 feet of fencing to use for the other 3 sides. What is the maximum area that he can enclose? Okay, now some of you already have the equation, but some of you don't. So I'm going to go ahead and find the equation here. We've got a riverbank, and we're going to do 3 sides of fencing. Okay. He has 120 feet for all 3 sides. We're going to call the short sides the width. We're going to make x, call those x, so the width equals x. The length would be 120 minus both of these x's. 120 minus 2x. Minus x would be a minus 2x. Okay, so the width is x and the length is 120 minus 2x. So the equation for the area is the length times the width, or 120 minus 2x times x. And so that is what we're going to put in y equals 120 minus 2x, close your parentheses, times x. And then we'll graph that, and we may or may not be able to see it. Okay, we can't really see it, so we're going to do zoom fit. And since we're trying to maximize the area, we want to find the maximum. Okay, and what this shows is a giant curve of the first part of it. So the maximum is way up here somewhere, and then it has to come back down. So we need to make x and y max a lot bigger. So let's go to the window. We'll make x max maybe 100. Y max is already 1,000, so let's make it 2,000. We'll see what happens. Oh, that's good. So we want to find the maximum up here. So we do second trace maximum. Push enter for maximum. We need to go to the left of the maximum first. So I'm moving my cursor to the left. Then I'll move my cursor to the right using the left and right arrow buttons. And then I'll push enter. And it gives me 30, 1800. And 30 is my x. 1800 is my y. 30 is the width. This is the area. You can do it like this. Okay, so what is the maximum area that can be enclosed? 1,800 square feet. And the width would be 30, and you could find the length. It would be 120 minus 2 times 30, which would be 60. Okay, number 13, describe the roots of the quadratic equation graph below. Okay, does this cross the x-axis? No, so this must have 2 complex roots or imaginary roots. You could put complex or imaginary. Okay, write a quadratic function whose graph opens upward and has roots of 3 plus or minus the square root of 5. Okay, now I'm going to show this. This would be for pre-AP. Also, regular can do it this way, but regular will have multiple choice. So let's see how this works. We'll have 3. First of all, let's write them separate. 3 plus the square root of 5 and 3 minus the square root of 5 are the 2 roots. Now to make factors, we do the opposite. We do negative 3 minus the square root of 5 and negative 3 plus the square root of 5, and then we put an x in front. Okay, and you can multiply all of this out if that's what you want to do, or you can use the shortcut. Now the shortcut is the first term is just x times x, which is x squared. Okay, this would be the first term. The second term is negative 3 plus negative 3. whatever these two are, we add those together, and that would be negative 9. And then the last term, or the third term, is negative 3 times negative 3 plus negative square root of 5 times square root of 5. So we do these two multiplied together and these two multiplied together and add them. Okay, so sorry about that, you can see that. So negative 3 times negative 3 is 9, plus negative square root of 5 times this negative, times square root of 5 is a negative square root of 25. So this would be 9 plus a negative 5, and 9 plus negative 5 is 4. Okay, so here's the first term. The second term we put in x, and then there's the last term. So we'd have x squared minus 9x plus 4. Or, I'd use the shortcut, but if you want to, you can just do x times negative 3, x times the square root of 5. Then you can do negative 3 times each one, then you can do negative 5 times each one, and everything's going to cancel out but what we have here. Okay, the last one. This is just a factoring problem. You're going to have a problem like this, and you're going to have to factor the numerator and the denominator. So we're just going to write 2 parentheses for the numerator and 2 parentheses for the denominator. So we have x times x is x squared, and either 6 and 1 or 3 and 2. Let's do 3 times 2, and if we make them both negative, then we get negative 2x, and a negative 3x is a negative 5x, and negative 3 times negative 2 is 6. We can do x times x for x squared here. 14 is 7 times 2, and we need a positive 5x, so we can do a plus 7 and a minus 2. That, when we add these together, we'll get plus 7, plus 5x, and a minus 14, and then you just leave it like this. The one on the test, these will not be the same. Okay. Okay. That is it.